Assalamu alaikum. This is the third part of first video lecture, which is related to earthquake disaster management. Previously, in this lecture, we have completed this first stage of disaster management cycle, that is mitigation. And one important point here related to mitigation is that mainly the safety of the buildings depends on the how much the codes or code provisions they are followed. And this was the reason that I showed you those videos of e-defense or the experimentation that was being conducted, because codes they are developed on the basis of experimental evidence, on the basis of numerical simulations, and on the basis of experience. So the first thing for any engineer or any structural engineer is to ensure the compliance of their designs with the codes according to which they are designing their structures. Like in case of steel structures, you have studied that we follow the recommendations by AISE. So accordingly, for concrete, we have a set of codes. ACI is there, or in European countries, we have in different countries we have different codes. So that was one important point, that these strengthening or retrofitting techniques, seismic proofing techniques, they are above the code provisions. That first we have to ensure that code provisions are met, and then to further improve the seismic behavior of those structures, we can include or incorporate these techniques. Then the next stage, that is preparedness. And in preparedness, the first or the important for any hazard, if we have the early warning system in place, that significantly reduces the impact of that hazard, because people or the community will be knowing in advance that that particular hazard is going to hit them. So for the case of earthquake, uh, the early warning system works, we have discussed it already. It works on the principle of the difference between arrival times or the travel times of P and S waves. This is one aspect of or the working principle of this early warning system, that at one particular point when the P wave is detected, depending on the distance of that point from the source, we will have more is the distance, more will be the gap between the arrival times of P and S waves. This is one aspect, and the second aspect is that more is the distance from the source to where the community is located, more will be the early warning time. If we have installed some sensor near to the fault line, so whenever there will be some movement detected on that particular fault line, the community can be, with the help of any communication network, nearby communities, they can be warned in advance. So the benefit of this warning that is mentioned in this paragraph, that this information can be used to reduce the damage, cost, and casualties in an earthquake, as this is enough time to slow and stop trains and taxiing planes, to prevent cars from entering bridges and tunnels. You have seen one video in which that bridge had opened up and a car was simply falling down. And similarly, in case of tunnels, both ends of the tunnels, they are most of the times trapped, or there is overall failure of the tunnel. So it is better that the vehicles they don't even enter the tunnels in case of an earthquake. So to move away from dangerous machines or chemicals in work environments and to take cover under a desk, we will see this thing in one of the videos that we have to see today. Or to automatically shut down and isolate industrial systems. You have seen in earthquake hazard videos that there was widespread fire disaster because of the gas that had spread after an earthquake. So on a community level, such supply lines or such supplies, they can be shut down whenever there are chances of an earthquake, or whenever there is an early warning that is issued. So the same P and S wave arrival time difference, that principle is mentioned here. So early warning systems, it is not very common at the moment. Only a few countries they have advanced early warning system. I think there are 8 or 10 countries in the world which have it. The reason is that you need to have a significantly high density of networks or sensors which should be spread throughout your country, so that whenever there is any earthquake motion that is detected or ground motion that is detected, you can dissipate that information and you can save maximum community. It won't be only one or two equipments which can do this job. As I have already told you in our previous lectures, that in case of Japan, there is more than 10,000 sensors or equipments they have been placed around the country. So whenever there is some movement that is detected in any part of the country, there is a central system or network which processes that information, and then any warning that is issued. Then the second preparedness measure, which is very stressed upon in developed countries, that is safety kits. So it can be implemented in different ways. In some countries, it is compulsory that every household must have, every office must have safety kit for each individual. And in some cases, on a community level, these supplies or these things should be available. So you can go through these items yourself. The idea is that if you are trapped inside a house, you must be having sufficient stock of items so that you can support yourself for certain period of time till the help arrives. Or the second thing is, like it happens in our far off areas where the help cannot reach directly. It takes several days for the government help to arrive or to reach to those areas. The people should be having, or the NDMA or the relevant departments should be having sufficient stock of items such as these bandage strips, the medications, other first aid supplies which are mentioned here, and similarly this sort of supplies which are necessary for survival, as well as which will be needed in case of a disaster. So you can go through these two slides yourself, but the idea is that you should know what are the very necessary items which should be present in the form of a packet or a box, should be placed near to the entrance of the house, so that whenever there is a disaster like situation, when you are trying to evacuate that house, you can hold that packet and you can simply move out, and using that you can help your neighbors, you can help your community fellows, or you can help yourself if those items are needed. So for that, you can search for some videos. You will find several example safety kits. There are means several business franchises which sell these safety kits in developed countries. So you can have a look. You can just search it online, and you will see several examples of safety kits which are being sold and the items that they contain. Then the next one is a proper evacuation plan. This is a third item in preparedness measure which can significantly reduce the chances of a hazard becoming a disaster. So two options can be there. One is a disaster plan like this, that you simply have to run without knowing that in which direction you have to move or where the exit is. But it has obviously, in one of the videos, if you remember, in case of earthquake hazard, I had shown you that one person was trapped inside a building and he didn't know that in which direction he had to move because he didn't know the exit for that building. There wasn't any sign which was directing him that he had to vacate that building in that particular direction. So one option is this one, but it is having its certain problems. For example, such incidents, such as the one which is mentioned here, that in case of an earthquake in Afghanistan about 4 years ago, there were 12 students who had lost their life. Even there wasn't any loss of life because of the earthquake itself, because the structures didn't collapse, but because of the panic and because the students didn't know that where they had to move. This was one incident, and there are several such incidents that people, they get trapped inside the building, or there is this crushing or stampede like situation. You must have seen, I'm not sure if you have noticed them or not, but in almost every room of our department there is evacuation plan that is attached or that is pasted on the wall, but the idea is not to just paste it there. The idea is to know that what is the emergency exit available in that room or in that hall in which you are going to arrange any seminar. So it is always a good practice that if you are inviting some guests, let's say for a conference or for a gathering, so you should know at the start of the conference, you should tell the audience that this is our secondary exit, this is the emergency exit, this is the main entrance and exit to the hall or room. So internationally, you will find this practice very common that at the start of any event, they first of all introduce the audience with the emergency exits or similar information that where they have to get water from or similar basic items. So then the opposite to this one, I have already told you that one option can be this one, but it has its own problems. Another problem can be that during earthquake, when people are simply trying to evacuate the building, there can be falling objects which will cause problems, which will cause injuries at least, and loss of life is also possible, which is a very common source of injuries, what we call as non-structural items being falling down. So uh, the better approach is to have a proper evacuation plan in place and to train the people or train the audience that how they have to behave during an earthquake, which is a very common practice in developed countries that since they have where they have the problem of earthquake frequently. There are regular training sessions, there are regular evacuation drills which are conducted almost after every 6 months or 3 months, even in certain cases. They conduct that training or drill, and one example of that I will be showing you here, and you will get an idea. Two important things you can see in this video. One is how you have to behave during the earthquake, and then how you have to behave after the earthquake. So this is one, the information mentioned here is that on this date, let me show you again, on this date in 2012, there was a 4.8 magnitude earthquake in China on this school building, and different situation of different classrooms that is shown here, that the students they were having their classes, then later on you will see that earthquake will be there. So the first thing that these students will be doing, that will not be simply to start running outwards, that will be to take shelter. Means every student is trained that they will be simply going under their desks to avoid any falling object hitting them. This is the first room which has observed or noticed the earthquake, and you will see that the students they have taken shelter. Since it is 4.8 earthquake, it is not that serious, but still in some other classrooms you will see that camera or the room will be moving, so you will get an idea about the intensity of the earthquake. This is another room. So such drills are very common, means at the mature level, in the university level even, we used to have such drills in Japan, that everyone used to exit the first, they used to take shelter, then on the other announcement they used to evacuate the building safely. This is another room, this is another room. I will skip some of the scenes, but you can find this video online. The teacher is asking or kind of forcing the students that they should stay inside the room and they should take shelter. Most of the students already know, only a few cases were there. Like you can see that the first tendency for some students is to evacuate, but at the same time they remember that in the rehearsals or drills they are taught that they have to take shelter. That is the first step. So then The second stage will be that the person overall the in charge of evacuation, or the headmaster you can say, they will be uh, evacuating the students from one classroom at a time, or two classroom at a time, to avoid the congestion or stampede in the corridors. So this is after the earthquake has stopped, the shaking has stopped. So to avoid damage from any you can say aftershock, or any fire incident, or any unstable structure, it is necessary that the residents should evacuate first. Then they should check or assess the situation, and then they will be coming back to the building if everything will be in perfect condition. So here, this is the second stage, that they are now evacuating the classrooms, one room or two rooms at a time. And you will see in the situation in corridors that they will be guided that these students have to move in this direction. The students evacuating from here will be moving to the other set of stairs, and you can see that there is no significant congestion or the chances of stampede. They are covering their heads to avoid any falling object, and they will be moving. You must have seen in front of department, or on the sides of the department, there are labels which are placed, or posters which are placed as the evacuation or assembly area. So that is the idea behind that, is to have an area where in such a situation people or the residents, they can evacuate, and they can be gathered there to check that everyone is safe and everyone is fine. So internationally, this is the, you can say, you can take it as a rehearsal or drill practice, that this is how the drills are conducted. This is not drill, this is a real case of earthquake, but in case of drill also, instead of the earthquake, there would have been a siren inside the building, and then the residents would have started taking shelter, or depending on the situation, they would start evacuating the building. So then this whole school, they will gather in the assembly area. So this is you can say a standard way of evacuating a building or behaving during an earthquake, which is followed instead of directly running out outside of the building. That will cause, or that has the potential to cause problems. When you have furniture present in your room, and when the room or the building is properly designed, then there are very less chances. Being civil engineers, we can say this, that because of the ductility of the structure, there are very few chances that the structure will be collapsing as a whole. There will be plastic hinges formed, there will be collapse in certain parts of, there will be cracking mostly, but if the structure is properly designed, there are less chances that it will be collapsing. So that is why the main focus should be to avoid any loss due to non-structural damages. And this is coming back to the disaster management cycle, which we had to complete. We have covered this mitigation stage already. This preparedness stage is covered now. And then the response stage, we have completed it. The rescue and first aid, obviously that is beyond the scope of this subject, but if there wasn't lockdown, or if the lockdown is over before the end of this semester, I will try to arrange a training session by rescue 1122 staff that will cover this part. And then the recovery, that is basically considering these mitigation measures. So if you have any questions related to this topic, you can ask in the comments, or as separate emails.